Thank you very much. Good afternoon, everyone. Thank you for being here with us. Okay, there's a clicker. Perfect. So the premise of this presentation is looking at how we can develop smart textiles, or we can reimagine the healthcare system, or how healthcare is delivered through a smart textile platform, or the smart textile IoT platform that we're developing at Myant. So this, I guess, problem statement begins with how the medical services exist right now in the current day and age that we have it. We are fortunate to be in North America to have access to healthcare, but that access is not readily available across the globe. The demand and supply, even within, I'm from Canada or even in the United States, is not meeting what is required. And the cost of healthcare services is increasing significantly. So how can we go about creating a disruption in the way healthcare services are delivered? So the first thing that we want to maybe tackle and go towards is moving away from a system that is reactive-based, or it's basically solving an issue that's occurred, to something that's a little bit more proactive and preventative. That's the first kind of objective that we have. Next is to move away from the system that's more around the brick and mortar of a hospital or a healthcare facility and receiving those services and making them available in the comfort of your own home. This will increase accessibility and access to care. The other condition is, if we were all to get a diagnostic of a certain ailment, we would probably get a treatment within a certain percentage here and there. How can we individualize the treatment to the user and make it more effective for them rather than being more of a gen pop solution? And last is, when you go to a physician, the physician will look at your treatment and what your problem is and only look at that one caveat, and they won't look at how it might interact with other kind of effects in your physiological control system. And that's not because the doctor has no interest in it, it's because the data is not available and they can't track that. So how can we create a system that is not just focused, but looks at the whole? Now, there has been attempts at this with wearables, but there are some shortcomings. There are two major shortcomings with wearables that we have today. Is one, the power. Every single one of these wearables has to have a separate power, and that will make it create friction in the adoption of the wearables or the smart units that you have. And over a period of time, once it becomes tedious, you just stop using it. The second more important thing is the data that's collected is fragmented and single modality, meaning that you have only singular modality data that's coming in. It's not aggregated in one central location, and the data does not speak to itself. And even if you have apps that aggregate the data, you don't have that cross-correlation of the data. So how do we go about doing that as well? There are other issues with regards to, people don't like invasive structures, obviously. Apple Watches and Fitbits have data accuracy issues. Tattoos are great, but they have a temporary life of 24 to 48 hours. And polar bands that exist, they're great, but they also have an adoption issue. I can't ask my grandmother or grandfather to wear that every day. And the reason being for this is these systems are designed by the researchers for the researchers. They're not designed for the user. So how do we go about cutting that cable and allowing the user to go about their daily life with these wearables, with these technologies, to capture the information accurately and continuously? And that's where we come in as Myant. So at Myant, we are developing the first textile IoT platform called the Textile Computing platform. This is a very simple and clean solution. Why? Because if you look around, everyone's wearing clothes, and we've been wearing clothes since the beginning of time. And you can cover it from head to toe with clothing. So if you want to sense, there is probably no simpler modality or medium than textile to cover. That increases the adoption, and these garments and textiles that we create have the ability to sense and actuate, which I'll go into later. And more importantly, they're washable. Like any other garment, you grab it, you drop it in the washing machine, and you go about your daily life. So you don't have much of a habit change or introduction of a new routine into your daily life. All right, and that's us, Myant, and we are a smart textile manufacturing facility located in Canada. At our facility, we produce the textiles, all the textiles and developments in Canada, Toronto. We are the first and only smart textile manufacturing facility in the world that has ISO 9001 certification for manufacturing. and is in the process of getting ISO 13485 for medical device developments. We have a exclusive worldwide partnership with Stoll, which is a flatbed knitting manufacturing machine that you saw there. We have an exclusive partnership with Carlisle, a yarn supplier, material supplier. And as well, we just signed an exclusive partnership with SMK in developing smart connectors to the textiles, and you'll see where that comes in. At Myant, we do the entire development, and most important piece of that pie is the beginning, which is the material development that goes into functionalizing the fibers and the fabrics and the yarns that we embed in the garments to serve the purposes and the applications that we have in mind. Now, this kind of ecosystem that we're producing at Myant, the uniqueness of it is the fact that we are an end-to-end facility. And what that means is we begin from the problem statement. What is it that we're trying to solve? At that point, we go into the materials development. We can extrude our own yarns, we cover our own yarns, or we wrap and combine different yarns, functional yarns, to create the fibers and the basically materials, the building components. From that point, we go into building the electronics, the mechanical, putting the system together, testing, validating it, whether internally or externally with our partners, such as Mayo Clinic or Toronto Rehab in Canada. And once we're happy with the results and validation, we go through the cycle, we can commercialize. And this end-to-end feature, which is allowing us to bring not only manufacturing, but smart textile manufacturing back to North America, is what has positioned us uniquely in the market. So what is so special about our team? Our team is the intersection of two major disciplines. One's a textile manufacturing component, and one is the engineering component. And in each area, discipline, we have all the subcategories and expertise. And why is this important? This allows myself as an engineer, as a biomedical engineer, to not worry about areas that are not my expertise, and working with my colleagues, disseminate information, learn, but also catalyze and accelerate the developments. It's not my job to go build an electronics component, or it's not my job to go understand what are the kind of intricacies of knitting or weaving. But if I can collaborate with someone that's been doing that for a living, that can basically speed up the process. And that's one of the issues with developing smart textiles. You know, you build the electronics in one part of the world, you ask for the textiles in another part of the world, and by the time you ship the whole thing together and try to put it together, you have to go through another iteration cycle that can take up to months. We do this within a week at most. So what does this allow us to do? This allows us to sense from multi-points on the body, from head to toe, as I mentioned. These are all the different sensing modalities that are currently available, and we currently do on our platform. For example, capturing the signals from your brain, EEG, the eye movements, EOG, capturing your heart rate, your muscle activity, your movement, your pressure, your joint angle, and we'll go into some examples of these. As I mentioned earlier, our system is bidirectional. What that means is it's very similar to the nervous system, where we have sensory, which is the afferent signal, and response, which is the efferent signal. And this bidirectional component is a very critical piece, because we don't want a system that just records. We want to have a response back to the nervous system or to the user, triggering them or informing them of an issue if it's occurring. And we have this in different modalities of mechanical, for example, heating, haptics, or shape-shifting. We have electric stimulation to either stimulate the nerves or the muscles. And we can have lighting modalities just to send notifications to the user if needed. So what is the purpose of all this? What we're trying to do is we're trying to create a digital understanding of the user, a digital understanding of the physiological control systems of the user. And the best analogy I have for this is every day when you guys wake up, if you have cars, you turn on your car, you have 100 bells and whistles checking from the fluid to the tire pressure to the battery level, but we don't have that for ourselves, and I don't understand why we shouldn't. You know, we sleep for 6 to 8 hours. That's a perfect period that we can capture information, and throughout the day, we can correlate the changes to our baseline from sleep during the day and what were the effectors that caused changes. So this is the idea of having this dashboard, and this looks at the 4 main physiological control systems in the body, being it biomechanics, biochemistry, electrophysiology, and hemodynamics. So in biochemistry, we are developing temporary and permanent chemical sensors that can be embedded in the garments, and they can analyze biomarkers in blood, sweat, or urine. An example here is a sanitary pad that can look at biomarkers in urine or blood. Here are some examples of how we do the chemicals or materials development in Myant. On the left-hand side, you can see the functionalization of a polymer. to develop a stretch sensor. And then once we're happy with or satisfied with the response of the system or the material, then we can either turn it into a yarn or a coating that we embed on the fabric. On the right-hand side, you can see some examples of some of the chemical sensors that we developed, whether they're pH, enzymatic, glucose-based sensing. And the key thing that we've accomplished here is a linear response of the system, which is very critical if you want to have a system to be able to track and correlate the readings to a basically a quantifying the value rather than having qualitative data. And the second thing is, if you look at the top plot, this system is reversible, meaning that once you wear the sweat sensor and the sweat sensor is activated, you don't need to drop your garment in the washing machine to reactivate it and to set it to the zero or to the baseline. There's a certain refractory period of the sensor that it can replenish itself and you can reuse it. And you don't need to do chemical sensing continuously, for example, through your sweat. So this can be tuned 3, 4, 5 hours based on the chemical sensor or the biomarker that you're tracking. Next is biomechanics, and this is capturing the movement of the limbs, the posture, the positioning of the trunk. And one example is a knee brace that we're developing, and this is being designed for people that have had potentially total knee arthroplasty, ligament damage with reconstruction surgery, or meniscus and arthritis. And it has stretch sensing to capture the knee angle for rehabilitation, as well as heating and stimulation for pain relief. Over here, you have some examples of our technologies that we're developing. These are all textile-based technologies. There's no printed electronics at all embedded in the fabrics. These are purely textile-based pressure sensing capabilities, whether they can be a bed sheet, a wheelchair, or just a car seat or an airplane seat. And we can also put it as a controller on a garment for individuals with disabilities that they can use that as part of a kind of a modality of communicating or basically a trigger for certain applications. And on the bottom right, the video is a little bit laggy, but we basically have that stretch sensor that I showed you a couple slides ago now embedded within the fabric, within the garment of the knee brace, and this was a prototype. We wanted to see if it makes sense. We developed the robotic knee and we put it on there and we start tracking it. As you can see, the response is quite linear and correlates to the knee angle. Next is electrophysiology, and this is essentially the electrical signals of the brain, the eyes, the muscles, and the heart. One example is our underwear, which is going to be launched this year. It's branded Skin, that can capture your full PQRST complex from either your waist or your chest. On the right-hand side, you can see how the underwear functions. We basically have your smartphone. You connect to the underwear with a Bluetooth basically receiver, and the data is transmitted to your phone and then to the cloud. And you can see the data is pretty clean as it comes raw. With a slight bit of filtering, we can make it even cleaner. We're currently working with Mayo Clinic in certifying this underwear as a medical device to detect atrial fibrillation continuously. And this can really change the way people are being diagnosed, or basically advance the diagnostics of any cardiac conditions. On the left-hand side, what you're seeing is a sleeve that we built that has 16 EMG electrodes on the forearm, and this is only to capture flexion of the fingers. What we did there is we started defining different finger functions, and the EMG was recorded. And if you have any experience with EMG, there's something called EMG contamination, meaning that if I flex my pinky or the middle finger, the region where the EMG is detected is quite close, so it's very hard to determine which one it is. So we developed a neural network that can decipher between the different finger functions and then translate that to the robotic arm that will mimic and repeat the same functions. Now, what is the purpose of this? What I developed this for was for rehabilitation. Someone that might have hemiplegia or might be remotely requiring some services. Someone could have the sleeve, let's say, here in North Carolina, and the recipient could be somewhere else in the world receiving basically the feedback from the therapist. You can also look at AR, VR applications and so on for this. Other examples are on the left-hand side. You can see a 12-lead ECG monitor, Holter monitor. If anyone's had any cardiac issues or been monitored for 48 hours, they're aware of the gel electrodes that they put on your chest and you have to wear it. We turn it into a simple vest that you wear with the electronics pod, and it's very comfortable. You take it off, you can dump it in the washing machine. In the middle, you can see a fetal monitoring pregnancy band. This essentially captures the mother's and baby's ECG. This is important in cases where they're not sure of the health of the baby and if they have to force labor. But even before that, you can track your baby's health. Over here, the reason why you're seeing wires is because this is part of a picture from our clinical trial. Once we have finalized the locations of the electrodes, all those wires will be embedded in the garment, hidden and not visible. And on the far right-hand side, you see an example of a headband that we made that can capture EEG and EOG. And later on, you'll see a video to that, and this is a published paper that we had worked on. Okay. All right. Okay, so just to take a step back here, these technologies that we're developing are not independent. They're all integrated and working together. So over here, I'm showing you an example of how we integrate biomechanics and electrophysiology together. There are mocap systems that can capture the movement of people, but they're very limited to the area that you're at, and there's blind spots, and it's not something that you can go about your daily life. We showed how you can capture movement. There's also another technology that's called electric stimulation. As you can see in the top right photo, that's how it's delivered. You attach a gel electrodes, you deliver the stimulation. Someone who's trying to recover from stroke or spinal cord can regain motor function. What we did is we took that and we turned it into a garment that can deliver the stimulation, much more convenient. The user can just wear it under their everyday clothes and go about their life, or deliver therapy at the comfort of their own home. They do not need to go to a healthcare provider, 1 hour transiting, 1 hour going back, and 1 hour setup time and dismantling. This can be done as many times as they want during the day, and it's not a surprise that practice makes perfect. So if they can do this over periods of time, they can improve. We had a clinical trial for this, 7 subjects, and all of them had shown improvements. In one case, which was a C5 Asia A, a total spinal cord injury, managed to recover, lost motor function, and lift up 1 kilogram of weight without stimulation after, I think it was 6 months of therapy. Our ultimate goal is to allow someone with spinal cord injury to stand up, and we want to simplify this to just a pair of leggings that you wear that will stimulate your muscles. With the stretch sensors and the pressure sensors, we can track the biomechanics of the user and correlate that to the stimulation and help the user, someone who's paraplegic, to stand using their own muscles. And finally, there's hemodynamics, and that's basically the fluid flow in the body, looking at blood pressure or listening, or a digital stethoscope that listens to the sounds in the heart if you have any atrial flutter or any basically leakage in your valves. We're turning this into a polo garment that can capture cuffless blood pressure from your arm. We're correlating this to the ECG data. We're creating a comprehensive suite of basically cardiac health through an underwear and a blood pressure shirt. As a matter of fact, this blood pressure already has ECG detection on it as well from the 2 arms, but I'm just saying if you have the underwear and the blood pressure shirt together, if you're moving your arms, you have EMG contamination, you have redundancies. So another example of how we integrate these technologies together, this is for sleep apnea, and I don't know if anyone's had sleep apnea or has gone to a sleep apnea clinic. It costs $1,000 a night. I went there myself. I was diagnosed with it. They asked you to sleep at 9 p.m. I'm a night owl, which was very difficult. I sleep at 1 a.m. usually. And then they stick all these electrodes on your head. They put something up your nose to capture your breathing, and they lie you down, and they're like, okay, relax and sleep. By the way, we're watching you. So it's just a very, it's not fun. And if you didn't have sleep apnea, you would definitely have it that night. What we're trying to do is we're trying to simplify this to basically the underwear and a sleep mask or an eye mask that captures your brain activity and the oxygenation from your forehead, and the underwear that can capture your ECG and heart rate, and correlating these two together can potentially detect sleep apnea every night that you wear it. And it could cost no more than $300-400 versus $1,000 a night, and we're currently in a clinical trial for this as well. And just to take a step back here, everything that you saw, or majority of the items that I showed you are garments, but we're a textile manufacturing facility. And one example of how we can functionalize textiles is basically car seats or seats that you're sitting on right now. We can embed different technologies in different layers of the textile. For example, we can put pressure sensing, and underneath it we can put heating and non-contact ECG, and we can put passive features, and these are material properties that will make this a non-cut, hydrophobic, and antibacterial fabric. So this all comes out in one go from the machine when we knit it, and can truly revolutionize in the future as we have more autonomous cars coming on the road, how user comfort and experience is using these modes of transportation. So what is the ultimate goal? Once we build our platform, which is going to be called Skin or Skin and Intelligent Interface, you have all these textile IoTs, the data is collected, it goes to your smartphone, that's sent to the cloud, the data is aggregated there, it will speak to itself, and you can share the data and the metrics with your physician, your healthcare provider, or your loved one. And this was a paper that was recently published by Eric Topol. He's a cardiologist and expert in AI for healthcare. And we believe that we're playing a major role in that vertical stack, providing quantitative data, accurate and continuous data that can be paired with qualitative data that you feed back into the app. And then using a neural network or artificial intelligence, we can decipher what's going on or predict. And as we progress and introduce these products to the market, and if we have 1 million users capturing data and we see something in a certain user, we can potentially predict that for another user and prevent and be advanced in preventing disease. And the best example I had of this, one person was describing it, is everyone's looking for the elixir of life. But if we can increase 1 million people's lives by 1 hour, that's 1 million hours, that's many lifetimes. So that's kind of our way of seeing how we can increase life and improve the quality of life. So everything you saw up to here was our kind of B2C, how we're introducing our products to the market, starting with the underwear and then the polo shirt. But we also have B2B endeavors. This is one example, is a Zoll Life Vest. This is a cardiac defibrillator garment. We're developing the next generation at Myant. This is a class 3 medical device. So if you have a cardiac arrest, the garment will defibrillate you. They're using our technology for knitting. They're using our technology for the electrodes and the stimulator pads, which are those two gray pads in the back, and there's also one in the front. Another example is Proteus Digital Health. This is a digital pill company. When you take the pill, and you can see the top of the top pill, there's a little black square inside. That's electronics. Once the pill is dissolved in your stomach acid hits the pill. That turns into a beacon, and it sends a signal identifying that you have taken the pill. Our underwear can capture that signal, and this has an immense future. We all know how expensive drugs are and how hard they are to come by, but is that drug effective? How much of that drug is being uptaken by your body, and what is the effect of it on your body? So once we finish this part of introducing the pill detection in our system, we can correlate when you took the drug, how long it took for it to kick in, and what are those metrics that are changing, namely your ECG and your HRV, but also if you're looking at galvanic skin response, and then you can tune your dosage based on your requirements rather than getting one set dose based on weight. So over here, I'm going to give you a couple examples of our B2A relationship, business to academia. This is the headband that we developed. This is for Jacob. This is Holland Blueview Kids Rehab, a rehabilitation hospital for children with motor neurological disabilities. So we built this headband for Jacob, and he couldn't communicate with his parents through speaking, but we made the headband that can capture his eye blinks, and using the eye blinks, we created a controller for him. This is the video. Do we have volume? Essentially, what's happening here is the research.
Nice job. That was a really good one.
That's okay. The researchers,
You're pretty good at this.
The researcher's asking Jacob, can you tell me a joke? And through his blinks, he's basically communicating with her and sending a joke. This was just a demo for TV, but what we eventually did was, through his eye blinks, we said, okay, I want to go to the washroom, I need water, I'm feeling cold. So that mode of communication was developed using eye blinks. And there are camera technologies, but you can imagine camera technology, it's obtrusive, it creates a stigma around him that he has a camera on his face. We just embedded this inside of a cap after it was done, and he just went about his life. And finally, this is Sam Schmidt. I don't know if anyone's into Indy race car driving. He was a race car driver, and he had an accident, and we developed one of those electric stimulation sleeves that you saw for him. We met him at CES last year, and remotely. And this is the beauty of this digital textile factory that we have, and the ability to do things without the need of cut and sew and basically measuring. He sent his dimensions to us from his therapist, and we never met him after seeing him at the show, and we went to him with the sleeve, and here's the video that I think will speak for itself. And by the way, Sam Schmidt is a complete quadriplegic, meaning that he has no movements in his hands or legs.
That's a big impact for Sam Schmidt there. The white car's just spinning down the middle of the track, and the worry there, of course, is...
I hit the wall doing about 185 miles an hour and backed in and As far as I know, it just blew everything apart in my neck. You kind of take it day by day. Days turn into weeks, and weeks turn into months, and the first thing I thought of 18 years ago when I was paralyzed is, I want to walk again. I want to walk my daughter down the aisle. Certainly haven't held my wife's hand, and haven't done that in 18 years, and meeting the group from Myant has re-energized me into trying to think of the possibilities and what's available. I mean, it seems like it's an impossible goal, but in meeting this group, it's not impossible. I'm blown away, and I think this can be life-changing.
So as you saw, that hand contraction that he had and his fingers moving was through the sleeve. And it was pre-programmed. We had pre-programmed the process of which fingers move in a certain cycle. So yeah, and in conclusion, we are open for business. We're looking for collaborations on the business-to-business side or business-academia side. Here's a list of a couple of the academic collaborators that we work with in kind of achieving these feats and these goals. And we truly feel and hope that by making this textile computing platform ubiquitous and available to the masses, we can make a change in people's lives and help improve the overall health of the society. Thank you so much.